So this is our second video in nuclear chemistry, and in this one we're going to talk about how you balance a nuclear equation. So the first thing you have to understand is that nuclear equations still obey the law of conservation of mass. Just in this instance, we are dealing with the mass-containing particles in the nucleus. So what that means is that the sum of the atomic numbers and the sum of the mass numbers on both sides of the equation have to be equal. So in this first example, we're going to look at how we would balance an alpha decay reaction. So in this case, we have uranium-238, and it's showing us that it's undergoing alpha decay. But we want to know what is the daughter nuclide that is formed. So we have two equations. We have the equation to find what the mass number is on top, and equation to find what the atomic number is on the bottom. So for the first equation, I'm just going to take what's on the left side of my equation, the total here, and I'm going to subtract the total here. So the top equation would be 238 minus 4, which says that this new nuclide has a mass number of 234. I'm going to do the same thing for the bottom equation. I'm going to take the atomic number total on the left and subtract the atomic number total on the right. So 92 minus 2 is going to give me 90. Then I'm going to go to a periodic table and find what atomic number 90 is, and that's the element thorium, which is symbolized by TH. So when I go back to my equation to fill in the missing nuclide, I write 234 for the mass number, 90 for the atomic number, and then TH for the element symbol. And now this is balanced because the total here, 234 plus 4 is 238, 90 plus 2 is 92, so it's balanced. This next equation is a little more complicated because now we have two things on the reactant side, two things on the products. But it's still just some simple math. I'm going to find the total on the reactant side for the top and the bottom, and then I'm going to subtract what's on the product side. So here we have an isotope of hydrogen and an isotope of beryllium are going to combine and then undergo alpha decay. So for the mass of the daughter nuclide, first I'm going to add together the mass numbers of the reactants, so 1 plus 9. And then I'm going to subtract the mass of the alpha particle, which is going to give me 6. For the bottom equation, I'm going to add together the two atomic numbers on the reactants, so 1 plus 4. And then I'm going to subtract the atomic number of the alpha particle, which is 2, which is going to give me 3. So my daughter nuclide has a mass number of 6 and an atomic number of 3, and atomic number 3 on the periodic table is lithium. So then this here would be my balanced nuclear equation.